Hey guys, I'm going to go ahead and work out 3 of the 4 problems that are on this systems practice sheet. Remember that Ms. Burat and I this week are teaching you the elimination method and word problems, okay? So before we get to word problems, because that's going to be kind of newer here, I'm going to focus on going through our criteria steps and solving this elimination method. So just like all the videos, please feel free to pause and make sure you're writing all the steps. This is not the kind of stuff that we want to skip steps on. So just like any other systems problem, the first thing I'm going to focus here is knowing that my answer is going to be an ordered pair. So I'm going to have an XY ordered pair. That is my goal of the problem here, okay? Now in elimination, we're doing the concept of adding 1 step to really saving ourselves 10 steps on the end. So I'm going to go first ask myself, is there a set of variables that I can eliminate right now? So obviously these y's are not able to eliminate and make 0 because 5 and -7 are not 0. 6 and 6 is close, but right now 6 plus 6 is 12 and that doesn't help me. However, I know using a multiple, I can multiply that entire equation by a number and make it easy to eliminate. So going back to that adding 1 step to save ourselves some more. So it doesn't matter which equation, but you're going to take one of these equations and multiply the entire thing by -1. And when we do that, we're able to now have 6 and -6, which is able to eliminate. So it's worth that little step. I'm going to write it underneath right here so I can easily cancel it with the bottom one and say that -1 times 6x is -6x. -1 times 5y is -5y. And -1 times 4 is -4. So I'm not going to use this equation. I'm going to use this equivalent form because it now has me to a point where I can say, well, 6x and -6x eliminate and make 0. And that was the goal the whole time. So now I can combine what I have left. -7y and -5y is -12y. -20 and -4 is -24. Now, this would be a great point if you want to pause and kind of work ahead and then watch the rest of it and see if you can solve it on your own. I think that would be a great idea. So no, go ahead and pause right now if you want to try. Okay, and if not, I'm going to keep solving for y and then plugging in to solve x. So now I'm going to say I want to get y alone, so I'm going to divide by -12 on both sides, which would cancel, and leaves me with my y variable of -24 divided by -12. Be careful with your sign here. A negative divided by a negative is a positive, and this goes into 24 2 times. So I have one of my variables in my ordered pair as 2. And now that I have that y as 2, I can go plug it into either of the original equations. And like I say in class, it doesn't matter which one. I pick the one that has the less negatives because that's going to be easier to work out in my opinion. But you pick whichever one is easier. I'm going to go copy this first one down here. 6x plus 5y equals 4. And what I'm going to do is literally replace y with 2 so that I can solve it. So I'm going to say 6x plus 5 in the place of y. I now know the value of y is 2. And then 5 times 2 is going to be 10. So 6x plus 10 equals 4. I'm going to bring this over as a minus 10. And I'm going to say that 6x equals 4 minus 10 is -6. And divide by 6 and divide by 6. And I'm going to get a value of x equaling a -1. And again, I'm going to come up to my goal box up here and say that I have an ordered pair value of -1, 2. And of course, just like any other equation, I could go take those x's and y's and plug them in to check as needed. Okay, so if you need to watch this strictly solving part again, go ahead and stop and rewind and just watch this again. I'm going to focus on the right-hand side now, which is the writing and solving of word problems, okay? So I'm going to be very clear about this from the beginning. This is a lot going on, and in 8th grade, you haven't written a word problem like this before because you're really writing 2. So you have to stay very organized, and you're going to have to name your equations and name your variables in order to stay organized, all right? So let's read this and kind of set it up. It says, Jesse and Jamie went to the store to buy king cake. So already I'm visualizing that 2 people are going to be buying 2 different things. That's going to be my 2 equations, and the 2 things they're buying are going to be the x's and the y's. Jessie bought 2 blackberry king cakes and 1 plain king cake and spent $32. Jamie bought 7 blackberry king cakes and 3 plain king cakes for $107. It's a lot of king cakes. Determine the cost of each type of king cake. So, like I said, in order for this to happen, you're going to have to set up an equation for each person, and then each person is going to have its own variable. So, first thing I'm going to do is write my bracket for the system, and then I'm going to name each equation. Each equation, each thing that's happening is Jessie's king cake totals and Jamie's king cake totals. So I'm going to say that my first equation is going to be called Jessie, and my second equation is going to be called Jamie. Now, what Jessie and Jamie both have in common is that they're both buying the 2 types of king cakes. The first one is what we're solving for, which I'm just going to simply go in the order of the problem, is X, which is the blackberry king cake. And then they both also bought Y, which is the plain. So it's almost kind of mapped out like a bracket here where I'm going to have Jessie's buying her X and Y and Jamie buying her X and Y. And now I'm going to kind of just go fill in what is what. So I'm going to go back to the problem and say Jessie bought 2 blackberry king cakes. Well, 2 of what we're using for X is going to be 2X. And she also, and as soon as I say also, that's going to trigger to say addition. 1 plain king cake, and 1 plain king cake here is Y. She spent a total of $32. Okay. And then I'm going to move on to Jamie. Jamie bought 7 blackberry, and again, he is also buying the X. So we're going to use this, start this for his equation. 7 blackberry king cakes and 3 plain. And again, Y is 3. So we have that there. And he spent a total of $107. Okay, so now we have the system written, which is honestly the tricky part because you are all very efficient in solving the equations, the systems now. So this is not a ton of room, and systems takes up a ton of room. So this might be a good point where you either want to write on your desk if your teacher's cool with that, or on the back, you're going to go to solve this. So I'm always going to pick elimination if I can. I'm going to pick that I don't have any factors that can help me with 2 or 7, but I can definitely make this Y a -3, so I can use that additive inverse of -3Y and positive 3Y. So what I'm going to do is simply transfer this system down here to my blank paper and say that I'm going to just copy the whole system right now. 2Y equals 32. And then 7X plus 3Y equals 107. And now I'm going to say, I know I want to cancel out these Y's, and I'm going to do that by multiplying by a -3 into everything in the equation. And what I'm going to do is to kind of stay organized, I'm going to write it right underneath so that those kind of that step of criteria where it said to line them up, it's going to put my Y's easy to cancel. And again, this is a video, so if you're moving fast, pause, go back, and keep watching. All right, so right here, this is going to multiply to be -6x. This is going to multiply right here. I'm frozen. There we go. -3y here. And then -3. Okay, no shame in your calculator, especially when we don't want to get all of this wrong for a sign mistake, is going to be -96. So I'm going to cancel. I'm going to combine. I'm so sorry. I didn't mean to draw a line through that. I'm going to cancel this. It's a good example, honestly, too, if you make a mistake here. That doesn't equal 0, right? We can't cancel something that doesn't equal 0. We want to cancel 3y plus a -3y because that equals 0. That's the whole point of eliminating. What we can combine, if I meant to draw a box there, is what's left over. We're basically combining the leftovers. So 7x minus 6x is just going to be 1x. And then 107 minus 96 is going to be 11. And let's go back to the big picture here. We solved for x and we found out what x was. And in this case, x was blackberries, and we were determining the cost of each type of king cake. So if we did that and we still have a goal box, even though it's a word problem, and I'll kind of zoom out a little bit, then that means that x is going to be $11, which is the cost per blackberry king cake. And then we're going to go do the same thing for y, which is going to be the cost per plane. So now that we have 11, I'm going to go back to the easier equation. In this case, I think that's probably going to be the first one, okay? And I'm going to say, I'm going to scoot this up a little bit because it's this equation right here. And I'm going to say that 2x, I know that 2x plus y equals 32. I like to write out the full equation. And then I'm going to go plug in x as 11. So 2 times 11 plus y equals 32. 2 times 11 is 22 plus y equals 32. Bring this over as a minus 22. And y is going to equal 32 minus 22 is 10. And again, we're going to go back to big picture here, okay? Big picture it's always an x and a y. But in this case, we're finding the cost of the x and the cost of the y. So x is 11 and y is 10. But in this case, it's $10, right? X is 11 and y is 10. So it's still an ordered pair, right? But in reality, it's also an actual value. So this is $10 cost per plain king cake. Okay, and again, that's a lot of scratch work. So please go back if you need to check any of this again, rewind and keep going. All right, so far, I'm going to transfer my answers here. We know that we had 11 and 10 as our values. And then, of course, you go back and, of course, can write in your box here that 10 is the cost per blackberry, 11 is the cost per blackberry king cake, and 10 is the cost per plain. Now, I'm not going to completely solve this one. I'm going to kind of set these last two up for you just as hints, and then you're going to be able to go check Ms. Burat and I's key as needed for this, okay? But since I've worked out one of each at the top, we'd like you to go try both of these at the bottom. So for this one, I'd like you to notice that you don't have something ready to eliminate. However, those X's look really easy to fix. So your hint here is going to be, you're going to need to multiply this entire second equation by a number in order to cancel it out with 2. So think to yourself, what is the opposite of 2? It's going to be negative 2. So you're going to have to make that X value a negative 2. All right. This one right here, you know you're going to be writing a system. And you know you're going to be naming each equation and naming the X and the Y. Okay, so this says Jacob bought some tickets to see his favorite singer. He bought some adult tickets and some children's tickets. The adult tickets cost $10 per ticket, and the children's tickets cost $8. So Ms. Burat and I have kind of already explained that sometimes it's a little bit easier to do ones where it's people. This is going to be a little bit trickier, easier math, but trickier setup because the equations are not people. Your equations are actually going to be number of tickets and then the cost of the ticket. So I'm going to set that up for you, but then you're going to solve. So this first equation here, we're going to talk about strictly the number of tickets. And what I mean by that is that we know he bought some adult tickets and some children's tickets. Well, I don't know either of those costs. I know that's what I'm going to be solving for, though. So I'm going to call X adult tickets and Y children's tickets. And I'm going to say if this equation is talking about number of tickets, I can say I don't know how many, but I know he bought some adult tickets and some children's tickets. And I know that there are a total of 9 tickets. Okay. Then I know that there's a similar situation. Obviously, it's the same amount of tickets, but we also need to talk about the price. So the adult tickets cost $10 per ticket. Okay, and notice now I'm talking about cost. So this entire equation is not necessarily the number of tickets, it's the cost of tickets. Okay, adult tickets cost $10 per ticket. So children's tickets cost $8. So think to yourself, what would I put here? Well, I would put 8. Why? Because it's $8 per children's ticket. And now they spent $76. So I set it up. What we would like you to do is solve it and see if you can put it back into the words correctly. And then you'll check Ms. Burat and I's key and email either us for any questions. I hope this helped. Remember, when I talk fast in a video, you can always pause and go back. And good luck.